Hello, my name is Evana Chaghouri and I'm presenting from Kuwait. Alzheimer's disease takes away more than just memory. It takes away identity. My research looks at why communication between brain cells collapses in Alzheimer's and whether supporting those systems can reverse the damage. Memory is not just information. It's how we recognize the people we love, stay connected to our past, and hold on to who we are. When brain cells lose the ability to communicate, those connections unravel. I wanted to understand what exactly goes wrong in that communication and what happens when those processes are supported. Looking across the research, three systems stood out to me as central to this breakdown. The first is calcium signaling. Calcium acts almost like a messenger that tells neurons and their support cells what to activate. If this signal is too weak or too strong, the entire process of communication breaks down. The second is AMPA receptors. These receptors sit at the synapse, the connection point between neurons. They are what allow one cell's message to actually be received by the next. Without them in the right place, the signal simply doesn't get through. The third is cellular maintenance. Neurons are constantly producing and recycling proteins and energy. If damaged proteins in mitochondria aren't cleared away, the buildup clogs the system and prevents normal signaling. Together, these three systems form the foundation of communication between brain cells, and when they fail, memory starts to unravel. My systematic review revealed three consistent patterns. Poor sleep was linked to shrinkage in memory-related regions, and in Alzheimer's models, this matched with weak calcium responses in astrocytes and overload in neurons. Both sides of the imbalance disrupted signaling. Correcting calcium levels reversed those effects. AMPA receptor trafficking as a common failure point. Different problems from metabolism to protein production to gene regulation all led to the same result. Receptors failed to stay in place and signals were lost. This was a shared point of failure, where multiple pathways converged. Stabilizing receptor placement reversed the signaling deficits. Cleanup systems as essential support. Even when calcium and receptors functioned, connections failed if damaged proteins and mitochondria piled up. The buildup clogged the system. Strengthening cleanup systems through protein recycling or mitochondrial repair reversed the communication breakdown. Together, these findings showed that while Alzheimer's disrupts communication in different ways, those effects can be reversed when the right systems are supported. This matters because restoring communication between brain cells is not just a biological fix. It's what allows someone to follow a conversation, recognize a familiar face, or remember a piece of their own story. Alzheimer's may take memory apart through many paths, but research shows that those paths connect back to common systems that we can support. If we can repair those systems, we may help people hold on to the connections that matter most. Thank you.